Let's talk about continuity. What does it mean for a function to be continuous? If you're taking calculus, this is a big concept within calculus that you have to deeply understand what continuity means, both in plain language and as a formal definition, because the AP exam will test you with the formal version directly. So let's define it in an informal sense. What does it mean for a function to be continuous? A function is continuous at a point if you're able to pick up your pencil and draw that graph without having to lift your pencil. And this essentially means there's no holes in the graph, there's no jumps, there's no breaks. Then that means your function is continuous. But that's not enough. You also have to understand the formal definition of what continuity means. The formal definition, so a function f is continuous at x equals a if and only if all these three conditions below hold. The first condition, f of a is defined. The second condition, the limit as x approaches a of f of x exists. And the third condition, the limit as x approaches a of f of x is equal to f of a. Read this third condition very, very carefully. It's the entire point of this video. The limit as x approaches a has to equal the actual function value at a. If all these three are true, the function is continuous at that point, and that's exactly the case we're working through today. And in order to make more sense of this, let's quickly go through an example. Say you have a question asking you to figure out if this function is continuous. The function itself is f of x is equal to x squared plus 1. I have the graph written here, but this is also a polynomial that you should be able to sketch quite easily. It's essentially the graph of x squared that's shifted up by 1 unit. And for us to determine whether this function is continuous, again, we have to make sure that the three conditions that I mentioned previously hold. So let's test each condition one by one. First is f of 2 defined. We have our function f of 2. In order to figure out if it's defined, we just have to plug in 2. So replacing wherever we have x with 2. We have 2 squared plus 1, which gives us 5. So it is defined and it's 5. The second condition that we have to make sure matches is, does the limit exist at 2? Since this is a polynomial, we can use that direct substitution. So we can just plug in the value straight in because polynomials are continuous everywhere, and this method always works for them. If you have other ways you want to figure this out, you can also use your graph. So long as you know how to sketch it and you know what this graph looks like, you can see that as we're approaching 2 both from the left and the right hand side, it's approaching a definite value. But for the case of this video, I'm just going to do direct substitution. So the limit as x approaches 2 of f of x would be, I substitute 2 in, 2 squared plus 1, which gives me 5. And then lastly, you want to make sure that the limit as x approaches 2 of f of x equals f of 2. So you're asking yourself, do conditions 1 and conditions 2 match? Condition 1, f of 2, and the limit as x approaches 2 of f of x from condition 2, they both equaled 5. So they do match. All the three conditions hold. F is continuous at x equals 2. And that's why the limit and the function value are the same number, 5. And that's essentially how you prove continuity. If this is an open or a free response question, you want to make sure that you have all your notations right and everything is written out properly, because you can always easily mix or lose points in that. I hope this makes sense. See you in the next video.